All right, so today we're going to talk about both perpendicular bisectors and angle bisectors. So we're going to start with the perpendicular bisectors. So you need to know for a fact that if CD is perpendicular to AB, okay, if you know that for a fact, and you know that AD is the same as DB, then you know that this is your perpendicular bisector. So if that's the case, point C right here is going to be the same distance from the endpoints of this segment here. So that tells you right here that AC is going to be the same value as CB, the length of CB. So if you have a perpendicular bisector, if C is on that perpendicular bisector, then you know that this segment and this segment are going to have the same value. Now it works in reverse as well. Okay, the converse of that theorem basically states, okay, let's say that you already know that C is the same distance from A as it is to B. Okay, and if you know that CD is perpendicular to AB, okay, so you know that that's a right angle, then you can tell me that, all right, AD is going to be the same as DB. Okay, so that is just going in reverse to what this one was here. So we're going to go ahead and apply that to a couple of examples. Okay, so pause it at any time if you need to get this into your notes. Okay, we'll go ahead and start this. So when you're ready, you can hit play again. So what we want to do in this first example is find the value of x. So we're going to look at what we're given. We are given that these two are perpendicular. We are also given that this is the same distance as this. That tells us this is a perpendicular bisector. So if we use this theorem up here, if we know that's a perpendicular bisector, we know these two distances are the same. So that would be this distance here would be the same as this distance over here. So that's the equation that we'll set up. All right, we know that 7x plus 24 is the same as 13x minus 48. So I want you to go ahead and solve this and see what you get for x. And then you can hit play again and see if we match with our answers. So I'm going to go ahead and continue with this. All right, so we'll bring our 7x over. So we have 24 equals 6x minus 48. We will add our 48. And that'll give us a 72 over here. All right, so here all we need is to find the value of x. So once we divide by 6, we will have that. All right, so x is a 12. Now they could ask you other questions about this. They could ask you what the lengths of these sides are. You would just plug your 12 in for x and calculate that length. All right, let's take a look at this next one. Now I want to add something more to this. We'll go ahead and find the value of x, but then I would also like to find the value of segment AC. Okay, so let's go ahead and label. We'll label that A, B, C, we'll call that D. So for your final answer, I want to know the distance from here to here. Now look at what we know. We know that these two sides are the same. So B has got to be on the perpendicular bisector because we have a right angle and it's the same distance from A as it is to C. If that is the case, then we know that these two distances are the same. So let's go ahead and set up an equation that will let us find x if we know that this distance is the same as that distance, because D would be your midpoint. So we know that 17x minus 3 is the same as 9x plus 13. So we'll go ahead and solve that, and we take our 9x to the other side. We have 8x minus 3 would get us 13. Let's bring our 3 over. And when we divide by 8, we get a 2. All right, so that's our value of x, and if that's all they wanted, then you would be done. But I want to go a step further, and I want to find what AC is. So that is from here to here. Well, all I need to figure out is what one of these lengths are. So we can pick either AD or we can pick CD. So if we find what AD is, we know x is a 2, so let's take 17 times 2, and that'll be 34 minus 3, and that'll get us 31. So think about what we can do if we want the entire thing, because remember, we know that these distances are the same. So if you want to find AC, all you need to do is take your 31 and double it. And you get 62. So pay attention to what they're asking for. They might just want to know the value of x. They might ask for another piece of the puzzle. All right, we're going to go on to angle bisectors now. So go ahead and put in what you have for angle bisectors. And let's take a look at what we have. Pause this anytime you need to and start it up again. So if we take a look at our angle bisector theorem, okay, we have our angle BAC right here. That's basically telling you if a point is on the bisector of an angle, then it is going to be the same distance from the sides of the angle when you form that right angle. Okay, equidistance, D to B as it is from D to C. Okay, if we know that this is an angle bisector, if these two angles have the same measure, then we know these two distances are the same. So you can really pick any point on this ray here and connect to the sides of your angle at a right angle, and you know they'll be the same length. So if ray AD, ray has a symbol with just an arrow, bisects angle BAC, and ray AB is perpendicular to BD, and ray AC is perpendicular to CD, then we know that BD, segment BD, is going to be the same value, congruent to segment DC. Okay, we're going to apply that in some of the problems that we do later. Okay, in reverse, the converse of that theorem. It says here if a point is on the interior of the angle and you know it's equidistant, the same distance from the sides of your angle, then this point is on the bisector angle. Then you can say this ray bisects this angle if you know these are the same distance. So we know BD and DC are the same, congruent. We know ray AB forms a right angle with BD, and ray AC forms a right angle with CD. If that's the case, then we can say that ray AD bisects angle BAC, or you could say CAB. Okay. That tells you that these small angles here, angle BAD is going to be the same as angle CAD. Okay, right here, these two angles right there. So let's see how we can use this. All right, let's continue with our examples here. We want to find in this one the value of x. I'm going to add on a little something extra to this one when we get to it. All right, looks like we are given that these two angles have the same measure. So we know this is an angle bisector. If this is the angle bisector, we know that these two segments are the same length. So we can set that up as an equation. We know the 9x minus 5 is equal to the 4x plus 30. So go ahead and solve that and see what you get for x. And then you can play it again and see if we match. All right, so that gets us the 5x minus 5 equals 30. We'll bring our 5 over. And when we divide by 5, we get our value of x equals 7. And again, it could go a step further. It could ask you for the values of these segments. You would just plug your 7 into your x value. All right, in our last example, we're going to go in the opposite direction now. This time we are told that these are the same, and we've told that they meet at a right angle with the sides of this angle. If that's the case, we know this is an angle bisector. So we need to find the value of x. That tells you that we can set those two values equal together. And then we'll find the measure of ABC, this whole thing. So first, let's find x. We know we've got 5x minus 11, and that should be the same as the other angle. So let's bring our 5x over. All right, make sure you bring your negatives down. That'll get us a 3x minus 41. We'll add our 41. And when we divide by 3, we get a 10 for x. So that is the first thing we had to find. So now we need to find this entire angle here. All we need to do is find the value of 1, and we can double that. So if we first find the measure of angle, say ABD, all right, that'll be 5 times 10, and subtract 11. That'll get us 39 degrees for that angle. So the final question is the measure of angle ABC. So remember, if this is 39 degrees, we know both are 39 degrees, so we just need to double that. And that'll get us 78 degrees. Whoop, there we go. All right, so when you come to class, just let me know if you have any questions on this.